Let's keep this radical party going, all right? We got example number 5 in the radical equations section. And once again, this will correspond to assignment number 14. And just look for that and download it and work it if you would, please. But this certainly would be a radical equation here because of that radical that's within it. And now, here's the thing. I would consider this to be what I would call the radical term because it's all held together with multiplication and division. All right, so when things are held together with multiplication and division, I consider that a term, and that's why I say get the radical term by itself. All right, so if we want this by itself, that would hopefully prompt us to add the 3x to the 4th power over to the other side of the equation, and therefore it now becomes radical expression, radical term, the fraction if you will, equals 3x to the 4th. All right, and then of course, after we get that radical term by itself, then we say, what would be the appropriate power that would get rid of that radical? I would point out that radical is a square root, so wouldn't the magic exponent be squared? That'll get rid of a square root. And again, if we do that over here, we do it over there. All right, now, the beauty of this question is that when we want to apply that power to that group, we're fortunate here because that's all division and multiplication. So again, according to the properties of exponents that we went over prior to spring break, I keep saying that, on assignment 3, it's okay in this example to go ahead and apply that, to drop it in there, if you will, to each one of these expressions. So therefore, 5 squared, that'll be 25. 2 squared, 2 times 2 is 4. And then the square root and the squared get rid of each other, x. That was the whole purpose in introducing that squared. All right, on the other side, power on a group, we're lucky. That's multiplication. Yes, the properties of algebra say that it is okay to apply that to each one of these. So 3 squared, 3 times 3 is 9. And then what do you do when you put a power on top of another power? Yeah, you multiply them. That's right, good, quick answer. I appreciate it. So 4 times 2, 8th power. And now we're basically out of the woods here. If you wanted to talk about what the appropriate flashback would be, the appropriate flashback here would be the fact that because of that 8th power, we're into the land of higher degree equations. All right, we covered that earlier here. So clear fractions, don't mind if I do. Wouldn't we need to get rid of that division by 4x with multiplication by 4x over 1, over 1. And if you do 4x over here, in order to kill the fraction, to clear the fraction, you need to do it over there. So on the left-hand side, they cancel each other and leaves 25. All right, so the left-hand side becomes 25. And on the right-hand side, we have one term being multiplied with one term, which will produce one term. And so the 4 times 9 is going to be 36. And when we have an x to the 8th being multiplied with another x, that becomes x to the 9th, doesn't it? All right. I think I'm dangerously on the edge of the screen, but I hope it's fitting. All right. Now look, the beauty of this one is that we're lucky enough to have the variable in one term. X is in one place. So the logic needs to be to use inverse operations here. And so in reference to the x, you would hopefully say, let's see, parentheses, exponents, that's what the 9 is, multiply. Look, that 36, that multiplier is further down the list. So we'll go ahead and divide both sides by 36. And by the way, if you grab a calculator and take 25 divided by 36, I think you'll discover that it's a nasty decimal, as we've called it, a messy decimal, right? So I'll just leave it in fraction form. Okay, and then how do you get rid of a 9th power? You'll use a 9th root. So we introduce a 9th root to both sides. And that'll get rid of and that'll leave just the x over here, which is the goal always, to get x by itself. And then it's like, I can't find my 9th root key on my calculator, Mr. Spaghetti Sauce. Well, guess what? that expression underneath has a first power on it. So again, as we've been saying, and this goes back to the discussion of higher degree equations, that could be written as fraction underneath here, raised to the 1/9 power. Yeah, and then we're going to have to put that in the calculator and see what we get. So, I hope you understand it's hard to talk about calculator usage when we're socially distant here. But parentheses, 25 divided by 36, close the parentheses, raised to the power of, parentheses, 1 divided by 9, parentheses. And let's go back and remind ourselves of what we were asked to do in terms of rounding. I believe this example said, sorry, that's a previous thing, I gotta get back to this one, but we were told 3 decimal places. So, again, I would caution you, for each assignment, make sure you pay attention to the rounding, because I will change it periodically. Mr. Soap Dispenser will change the rounding from one assignment to the next, so just pay attention. All right, but anyway, that should come out to be 0.960, and there you go with example 5.